Hello, my name is Nathalie Baracaldo and I'm the manager of the AI Security and Privacy Solutions team at IBM Research in Almaden Research Center, California. And today I'm thrilled to talk to you about privacy and business process management. To begin, I want to overview about some of the techniques that people are using to address privacy in this domain, and then we'll highlight some of the challenges I see in this area. Additionally, I am going to provide a deep dive into federated learning, which is a new paradigm to train machine learning models privately that I feel can open very important avenues for the business process management. I think we can all agree that data and analyzing data provides great values to all our processes by helping us understand how to reduce overheads and also to reduce cost at the end of the day. The problem that we have really is that some of that data contains private or personal information, and also it's protected by regulations like GDPR and HIPAA. How do we deal with that? Well, currently there's been a trend of using different privacy-related techniques. For instance, naive anonymization, where just the identifiers of the data are removed and then the overall data mining algorithms are run. The problem with that is that we all know that it's possible to de-anonymize that information, which can lead to really bad situations on people obtaining private data. For that reason, K-anonymity has come a different type of approach, where the idea is that your records, you take the private records and you group them together into groups of K, and hope that by having that group, by hiding the records in a group, you will actually protect the privacy of the individuals in those groups. The issue with that is that if the adversary has background knowledge, then he can still de-identify some of these records and basically know the private information, at least with certain probability of certain individuals. So that is problematic. For that reason, most recently, people have started to use differential privacy. One of my papers with some of the colleagues in this conference really tries to incorporate differential privacy mechanisms into the business process mining techniques. So what are the challenges there? Some of the challenges include getting to know what epsilon value you want to use for a particular application, because this epsilon really reflects how different a record needs to be in order to be considered private. So if you use an epsilon that provides way too much privacy, you at the end of the day end up reducing the accuracy and overall performance of your analytics, so that's bad. But if you don't use enough epsilon so that you can protect the privacy of the users, then it doesn't really work either. So just coming up with that epsilon for real use cases, it's one of the challenges for applying this type of technique in real life settings. Now, I want to talk about another direction today using my last 5 minutes that I feel it's very important. And I have been working on it for the past few years at IBM, and it's called federated learning. So in federated learning, it just basically arose around in 2016 because of this same tension that we see in business process management, where we have private data that we cannot really touch, but still we want to collaborate and to be able to extract insights from that data. So in federated learning, the idea is that you train a single model without among different participants that have their own data locked in silos. So how does this whole magic happen? First, we have introduced an aggregator. And what you're seeing in the screen are the parties. These parties have different information that it's relevant to the process mining. So, or to the machine learning. Let me just explain in the machine learning word. So each of the parties have their own data. The aggregator orchestrates the learning as follows. First, it sends a query to the parties. The parties use each their own local training data to answer that query and reply back with a model update. Once all the participants have answered to that query, then the aggregator can fuse or aggregate those model updates to come up with a next model. So what are these model updates and why they are private? Well, first of all, you can notice in this process that we never have the data leave its owner. It stays where it should be. And then these model updates are aggregated. For instance, if we were to train a neural network or a logistic regression, we would just exchange weights from the model and send them back to the aggregator. So some of you may be thinking, okay, this is great. We have a new model that we built together with all the participants, and now we have access to data that before was completely impossible to access. And you're right. Now, some of you may start thinking, okay, so what about inference threats in this scenario? And it turns out that some of my work in this area considers these inference threats and utilizes differential privacy and multi-party computation techniques to prevent that type of inference threat. In particular, if you consider that sometimes we don't want to trust fully the aggregator. So there's a whole spectrum on how we can run federated learning in these settings. The next question is, okay, this is all based on machine learning models. So how can we do some process mining utilizing the paradigm from federated learning? And here, one of the challenges is actually taking all the algorithms that we know for business process mining and translating them into this new paradigm. This requires basically making sure that we can utilize the data locally and just exchange deltas among different participants to find the final model. If you are interested to learn more about federated learning, to get really used to it, and if you want to try it out with a real enterprise framework, I invite you to check IBM Federated Learning. We created IBM Federated Learning with the user in mind. So you don't have to learn any new languages in order to train machine learning models in federated learning settings. In fact, we support some of the most popular machine learning libraries, including sklearn, Keras, TensorFlow, PyTorch, and Arly. So you can specify your model the way you usually do, and then let the framework do the inner work. I have included here several links that are useful, including the one to our Git repo where we have our community source. You can also check our IBM Federated Learning Enterprise white paper and visit our website for a lot of papers and other resources. So thank you all for listening, and I'm looking forward to answering your question and talking to you in our conference session.